Okay, so in this video I want to show you how I am classifying the images in the first instance. So I have just created this small program in Python using OpenCV, and so what it does is that we're going to iterate through the whole database that we have created a few months ago. And so, as you can see, you get this kind of a screen right over here, in which here you have the whole screen, and here you have the ROI, right, the region of interest of the image. So I have made some commands with the keyboard so that I can move freely around the image, and so that I am able to classify. Okay. From that, I have also set some commands to resize the window, so I can resize that to be a 12 times 12 frame, to be a 25 times 24 frame, and to be a 50 times 50 frame. Okay, so we're just going to take this analysis, but with this image. Actually, the previous one was better, but we can do with the same with this. Okay, so the point is that we move through the image using the commands that I have set with the keyboard. It's very easy to do. And the point is that, for example, I want to classify this little frame from over here to be a tuberculosis bacteria. Okay, but suppose that I decide not to use 50 times 50 frames and I decide to use 25 times 25 frames. Remember that I want to treat this as an OCR program, so it's gonna be kind of like that. And so we just position ourselves right over here. Over here you can see that the small chunk of the image is present, and right over here you have the a small vlog that shows where you are. Okay, so if you press H whenever you are here, then that's going to compute a histogram of that part of the image. And so as you can see, here we have a high level of blue, of course, as in all the parts of the image. So you can download this program to try to play with this. Okay, so remember that this is useful for anything that you can see on the microscope. With the automatic digital microscope, you can do that. And I don't know. Oh yeah. And the most interesting part that is going to help me classify the images is I don't know if you have read the previous log, but it said that humans have a lot of error. If, for example, you look at this image that you have over here, and it's the same as in the microscope. Okay, it's the same image. So if you try to find bacteria in here using only the microscope, not using a digital image, there is a low sensitivity. Why? Because it is very hard to differentiate the bacteria from the background. So, for example, we have this small chunk right over here, and I just want to note, by the way, this small chunk from over here, it's a bug which I'm lazy to fix right now, but it doesn't matter. You can do the same, because the one that is right over here changes, and it's just fine. Okay, because you have this. So, as I was saying, suppose that you have this small ROI over here, and if you're in the microscope, then that's hard to see. But if you use this software, and I mean you let the computer classify this, then the sensibility is going to increase a lot more. So we can represent that with the results that we have computed so far in the last two logs. But the problem with this is also the level of specificity. That kind of drops down due to the to the robustness of the algorithm, which confuses some things with bacteria. Okay, and that's why we have kind of a low specificity, but we achieved a great sensibility. Okay, and so continuing with the same stuff. I show you the histogram. I show you how you can move through the image, and we were actually analyzing this. So in order to make sure that I am correct, I'm going to press another key, which is the theta, and the theta is going to show me two things. It's going to show me one frame which has I mean, these two frames from over here that compute the detection algorithm, the version number 0 that I have made, and it has the color filter, it's got the shape descriptors, and it's got the polygon approximation. Okay, so as you can see, the algorithm got this wrong, but we can analyze others such as this. And so if I press theta, then the algorithm classifies this as as a bacteria. Okay. Why didn't it classify this? Perhaps because it looks like more like a circle and it's not well denoted, so it's better not to classify this as a bacteria and to classify this as a Fuchsian precipitation. So if we just come here, then we have another one. Of course, this is classifying this as a not bacteria because it does not have enough size. Then we can move here. This classifies as a bacteria. Then this is of course a bacteria, so we will classify this, and so on. Okay, that's the one. Okay, so this is what you can do with the program right now, and well, that's it for the video. Yes, I'm classifying the images using this program, and oh yeah, what I forgot is that for example, I say this to be a bacteria. Okay, and so as this is a bacteria, then what do? I press B to classify this as a bacteria, and I press N to classify this as anything else. So this is what I'm doing tonight, and by the morning I hope to have a neural network at least trained with a training set with a cross validation set. So I hope this works, and I know that this is going to be extremely workful because for the point of view that I'm taking this problem, it's kind of easy to resolve, okay? But we will see.